Okay, so today we're talking about inverses. So it says the word inverse has been used in various ways. Where else have you seen it? So there's lots of different things. We could say we've seen it with additive inverse. So if I say like the additive inverse of 3, it would be -3. We just say multiplicative inverse. Inverse functions can be used to find prices before taxes, discounts, extra charges, stuff like that. Okay, so inverse relation. So example 1 says find the inverse of the relation, then graph the inverse. Okay, so here's our relation. So relation is just like this set of points. So if I want to find the inverse, if you think about inverse, it's switching. So we're going to switch the x and the y's. So this first coordinate point is 0, 2. It's going to switch to be 2, 0. So then this next one, 1, 4, switches to be 4, 1. 2, 5 switches to be 5, 2. 4, 6 switches to be 6, 4. And then 8, 7 switches to be 7, 8. So let's go ahead and graph the inverse. So 2, 0, 4, 1, 5, 2, 6, 4, and 6, 7, 8, 5, 6, 7, 8. Okay, so there's the inverse. Now this says graph both the relation and its inverse and connect the points. So here's the inverse that I just did. There's the inverse. So I'll do the relation in a different color. So the relation is this set of points over here. So 0, 2, 1, 4, 3, 4, 2, 5, 4, 6, and 7. Oops. Yeah, 4, 6, 8. 1, 2, 3, 4. Oops, that was supposed to go there. Messed up. 0, 2, 1, 4, 2, 5, 4, 6. Sorry, that one's a mistake. And then 8, 7. So 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 4, 6. Try again. Oh my goodness. Just messing up everywhere. Okay, so here it is right here. You can ignore my 2 mistakes there. Okay, so the relation, on the relation, which is this original right here, let's label the domain. So the domain is our x values. So 0, 1, 2, 4, and 8. And our range is our y values. So 2, 4, 5, 6, and 7. Okay, now for the inverse relation, things just switch. So just like to get to here, you want to make yourself a note. We switched x and y. So same thing happens with domain and range. So the domain here becomes the range, and the range becomes the domain. So here for the domain, we're going to say our x values are 2, 4, 5, 6, and 7. And our range is 0, 1, 2, 4, and 8. Okay, so it says the relation is inversed and the graph is reflected over the line y equals x. So if I draw the line y equals x, it goes straight through the origin and it has a slope of 1. So it goes straight through here. So if you have a relation and its inverse, what happens is it gets reflected over this line. So if I take every point on the relation, which is the blue one, and I flip it across, I'm always going to go directly across like a mirror image. And then this one gets flipped over here. Okay, so example 2 says graph f of x equals x squared and its inverse on the same graph. Okay, so let's graph x squared. So x squared, you could put in your calculator if you wanted to get a couple points. X squared. So we know it's just a parabola, and then we could go to the table of values to get some points here. So we have 0, 0, 1, 1, 2, 4, And we'll do, let's see if I can fit, I can't fit 4/16. Now we'll go -1, 1, and -2, 4. Okay, so there's x squared. Okay, so I haven't taught you to find the inverse yet because we're going to do it on the back. So let's first look at this inverse notation. F of x is going to be our original, and then this is going to be the inverse of that. And so in this case, the inverse is plus or minus square root of x. And I'm going to show you how we find that. Now, if I graph this square root of x, I'll graph it in purple here, it looks like so remember, you can take, even though you don't know how to find the inverse function, you can take, so I should actually just erase that, like this. You can take those coordinate points of x squared. So some of the coordinate points we used, 0, 0, 1, 1, 2, 4, we use -1, 1, and we use -2, 4. You can take those coordinate points and just switch them like we did up top. And so that's how I'm getting the inverse function. So if I graph this, it looks like that. And again, it's as though I just reflected it across that line, y equals x. So if I reflected it across this line right here. Okay, so it says, is the inverse a function? Well, let's review, how do you figure out if something's a function or not by looking at the graph? In order to do that, you're going to do the vertical line test. Okay, so our original, this parabola here, that is a function because it passes the vertical line test. But our other one, if I draw a line straight through it like this, it hits the graph at 2 points. So it doesn't pass the vertical line test. So the inverse is not a function. So an inverse relation may or may not be a function. But also the function may or may not have an inverse. So you might not be able to do the inverse of a function. So it says when the relation is a function, you can write the inverse of a function f of x as f inverse of x. Okay, so that's your notation, and it says it does not indicate a reciprocal. So if we're talking about like 1/2, and we do, where we flip it and we do 2/1, that's not what we're talking about here. We're talking about the actual inverse function or inverse relation, okay? So it says if f of 4 is 6, so this is telling me f of 4 equals 6. Now remember, when we talked about this, the 4 is an x value, and what we get is a y value. So what do you know about f inverse of 6? Well, that means that f inverse of 6 is just going to equal 4, because remember, we're just switching x and y here. So now this is our new x and this is our new y. These two just switch, and this is our notation that we use. So if you're given a function, you can find the equation of the inverse. So this is important, how you find the inverse. Let me highlight that, how you find the equation of the inverse. Okay, we're going to switch x and y. So we're going to switch x and y and then solve for y. So most of our equations right now, like here, this one's f of x. This one already has a y though. So we talk about this all the time when we talk about f of x. F of x is the same thing as y. Okay, so what I would recommend first here is go ahead and change this f of x to a y. So y equals 7x plus 2. Okay, so that's our function that we're starting out with. So now we want to find the inverse. So we're going to switch the x and the y. Now this is just literally switch places here. Okay, so the x, I'm going to say x equals 7y plus 2. So all I did was I literally just switched the place of x and y. Now I want to solve for y. I want to get y by itself. So I'm going to subtract the 2 over. So x minus 2 equals 7y. And then I'm going to divide by 7. So y equals x minus 2 over 7. Now when we write that, we're going to write that as f inverse because we found the inverse. So I'm going to say f with that little -1 of x equals x minus 2 over 7. So this is the inverse function. Okay, it says state its domain and range. So if you look at this, 7x plus 2, this is a linear equation, which means it's just a line. So the domain would be all real numbers and the range would be all real numbers. So when we switch here, domain is still all real numbers and range is still all real numbers. Okay, and you could graph that to check it if you wanted to. You could go ahead and graph 7x plus 2 and see that it's a line. You could graph x minus 2 divided by 7 and see that it's a line. So there's our domain and range. All right, so let's try another one, B. So we already have the y here. So remember, first thing we're going to do then is switch x and y. So literally change places. So we have x equals y plus 8 divided by 4. So I took x and y, just switched them. So now we want to solve for y. So I'm going to multiply both sides by 4. So 4x equals y plus 8. And then subtract the 8 over. So y equals 4x minus 8. So we write f inverse of x equals 4x minus 8. So there's our inverse function. Okay, now this started out as a linear equation. Again, you could graph that if you want. So then this inverse function is still linear. So our domain and range haven't changed. Still all real numbers and all real numbers. Okay, C. So we have f of x. So let's go ahead and change that to be a y equals square root x plus 5. So again, we're going to switch x and y. So x equals square root of y plus 5. Now we want to solve for y. So subtract the 5 over. X minus 5 equals square root of y. And we're going to square both sides. So now y equals x minus 5 squared. So we say f inverse of x equals x minus 5 squared.